What if instead of being asked to simply verify that two functions were inverses or to determine if two functions were inverses, what if you actually had to find an inverse function? So before I talk about how to find inverse functions, we have to talk about whether or not a function has an inverse. So remember that in order to determine if a function is a function, we needed every single x value to have one y value. For example, if you had the point, say 2, 5, you could not have the point 2, 3 because I would fail my vertical line test, so that would not be a function. However, I could have the point 2, 5 and the point 3, 5 because even though I have an overlapping y value, I still would have passed the vertical line test if both 2 and 3 shared a corresponding y value. So that would be a function. In order to have an inverse, we have to not only be able to pass a vertical line test, we have to also be able to pass a horizontal line test, meaning that every single y value has to have one x value. So, just like the x value of 2 could not have two separate y values, a y value of 5 could not have two separate x values because it would fail a horizontal line test. So our first step in finding an inverse is always going to determine if it can even exist. We have to make sure that we have a one-to-one function that would pass a horizontal line test. Often to create a one-to-one function, inverses are, domains are restricted, and you'll see some of that, if not in the upcoming examples, then in some examples that we look at in class. What we're going to do then is we're going to, if it is written in function notation, if I have f of x, I'm going to first replace f of x with y, and then I'm going to switch x and y around. I will solve my equation for y. Then I need to acknowledge the fact that what I just found isn't actually y, it's my inverse. So I'm going to replace y with my inverse notation, and then if there are any restrictions that need to be stated, I can state restrictions at that point too. So I think I have quite a few examples here, so let's look at the first one. So on the first one, I want to find the inverse of f of x equals 3x minus 7. So first thing I'm going to do is say that's the same thing as having y equals 3x minus 7, and then switch x and y around. So if I rewrite this as x equals 3y minus 7, and then solve this for y, I would have to add 7, and then divide by 3. And now that y is by itself, that's going to be my inverse function. This right here is my inverse function, so I need to label it with what it is. So I can say f inverse of x is equal to x plus 7 over 3. And there's my inverse function for the first example. Looking at a second example, I'm going to do the same thing. First thing I'm going to do is say y equals 2x minus 4 all over 7. So that I can then switch my x and y around. Therefore, x equals 2y minus 4 all over 7. So in an effort to get y by itself, I can now multiply by 7. And now I can add the 4 and then divide by 2. So 7x plus 4 equals 2y, and 7x plus 4 over 2 equals just y. Now that I've found my inverse function, I have to label it with what it is. So my function was f, so I'm going to say f inverse of x is equivalent to 7x plus 4 all over 2. And remember, if I'm ever unsure about whether my answer is correct, I can always check my inverse by going ahead and saying, does f of f inverse go back to x? Does f inverse of f go back to x? So I do always have that check to fall back on. Looking at a couple more examples, I think I have 2 more examples. I want to find the f inverse of f of x here. So again, I'm going to start by saying that means that y equals x plus 1 times x plus 2. And now I can go ahead and switch x and y around. So x equals y plus 1 times y plus 2. Oh, looking closer, I realize I wrote that wrong. There's supposed to be a division bar in the middle there. So I'm going to rewrite this as x equals y plus 1 over y plus 2. my typing is too small. So now from here, I want to go ahead and solve for y. So I'm going to multiply both sides by y plus 2 because I don't want that y plus 2 in the denominator. I'm going to have x times y plus 2 equals y plus 1. I'm going to go ahead and distribute that x in because I'm probably going to need to be able to move my y's around because I'm going to want to get my y terms on the same side. So I'm going to have xy plus 2x equals y plus 1. From here, I'm going to go ahead and I'm going to subtract 2x from both sides and also subtract y from both sides. So let me try to squeak that in there in a different color. So I'll subtract 2x and I'll subtract 2x. I'll subtract 1. Excuse me, not 1. I want to subtract y. Subtract the y. Subtract the y. Giving me xy minus y equals 1 minus 2x. I can now factor a y out of my left-hand side and get y times x minus 1 equals 1 minus 2x. And finally, to get y by itself, I can divide by x minus 1. So I get y equals 1 minus 2x all over x minus 1. Now that I've got y by itself, I can go ahead and relabel it as what it is. It is f inverse of x, and it's equal to 1 minus 2x all over x minus 1. So just again, really quick, because these types of problems sometimes I see them give difficulties to students. So I got my variable that I was solving for out of the denominator by multiplying both sides by my denominator. I distributed the x because I could see that if I could get this y out of the parentheses, I could collect my like terms on one side of the equation. So after I distributed, I wanted to move this y over to the left, but I needed to get rid of the 2x because if I had the 2x over here, I wouldn't have been able to factor out a GCF of y. So I moved my 2x over, I moved my y over, resulting in this piece here, and then was able to take a y out. Looking at the third and final example here. First thing I'm going to do is I'm going to say y equals 2 times the square root of x minus 1, which means x equals 2 times the square root of y minus 1. I can start by dividing by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. So I'm going to go ahead and say 1/2 x equals the square root of y minus 1. So I can get rid of that radical by taking the square of both sides. I have to square this entire side. Remember, squaring means multiply by itself, so 1/2 x times 1/2 x becomes 1/4 x squared. My square root and my square cancel here, leaving me with y minus 1. I can add 1 to get y by itself, and then I just have to relabel it as my inverse. So f inverse of x equals 1/4 x squared plus 1.